Hi all, here we're going to learn about Euclidean algorithm, which is used to calculate greatest common divisor of two numbers. Euclidean algorithm is more efficient when you have two large numbers that you need greatest common divisor of. It's much easier to use than factoring if the composite numbers are really big. So we're going to look at two natural numbers a and b, with a being greater than b, and we will be rewriting a in terms of b times a quotient plus r. So in this equation, a is rewritten as b times a quotient q plus r, and r has to be greater than or equal to 0 and less than b. So here we have to find greatest common divisor of 240 and 2700 or 2700. Now you start with picking the larger number. If, for example, if I start at 240, and 240 is not large enough to host 2700. This is not going to work. This is why you always start with the larger number, which is 2700, and you're going to rewrite it in terms of the smaller number. In this case, the smaller number is 240. 240 goes into 2700 11 whole times. You can find that easily by dividing 2700 by 240. And you will get 11.25. 240 times 11, that's 2640. You need to add 60 to have the equality. And the easiest way to find the remainder is to take 2700 minus 240 times 11, and you will get 60 as a result. Euclidean algorithm is a pattern, so the next step is to copy the equal sign. Now you will drop 2700, and we're going to take the next number that we used, which is 240. So you drop 2700. You will also drop the quotient. We don't care how many times 240 goes into 2700. And you're going to copy the remainder, which is 60. Now we're going to rewrite 240 in terms of 60. Now 60 goes into 240 4 times. 60 times 4 gives us 240, and the remainder is 0. Once you hit 0 as your remainder, once you reach a 0 as the remainder, previous remainder becomes your answer. So greatest common divisor of 240 and 2700 is 60. Let's find greatest common divisor of 1539 and 3144. Now 1539 is not large enough to be rewritten in terms of 3144. So you start with rewriting the larger number, which is 3144, and it's equal to, in terms of the smaller number, which is 1539. 1539 goes into 3144 2 whole times. 3144 minus 1539 times 2, the remainder will be 66, so plus 66. To make sure you're doing it properly, this expression has to be equal to 3144, no more, no less. So since the remainder is not 0, we apply the algorithm. You redo this until you reach 0 as your remainder. So the first thing to do is to take the number after the equal sign and you drop the previous number and you have 1539. We do not care about the quotient, but we do care about the remainder, so we're going to copy the remainder up front. So we have 66. 66 goes into 1539 23 whole times, and 1539 minus 66 times 23, the remainder will be 21. Since the remainder is not 0, we apply the algorithm again. So we take the previous remainder, which was 66, we move it across the equal sign. We do not care about the quotients, we just care about the remainders. So we have the previous remainder was 21. 21 goes into 66. 66 divided by 21 is 3.14. Dun. So 21 goes into 66 3 whole times. 66 minus 21 times 3, the remainder is 3. Since the remainder is not 0, we apply the algorithm again. So we copy the equal sign, you move the previous remainder up front, which is 21. You don't care about the quotients. We want to copy this remainder again and rewrite 21 in terms of the previous remainder. 3 goes into 21 7 times, plus the remainder is 0. 21 minus 3 times 7 is 0. And the solution is the previous non-zero remainder. So greatest common divisor of 1539 and 3144 is 3. Let's find GCD of 240 and 378. So the first thing to do is to rewrite larger number in terms of the smaller one. So the larger number is 378, and it will be equal to 240. 240 goes into 378 one time. 378 minus 240 times 1, the remainder is 138. The next thing to do is to copy the equal sign. We drop the first number, then we rewrite the smaller number, which is 240, in terms of the remainder. So we have 138. 138 goes into 240 one whole time. 240 minus 138 times 1, the remainder is 102. Since the remainder is not equal to 0, we do the algorithm again. So we take 138, we move it across the equal sign, and we rewrite it in terms of the previous remainder, which is 102. We do not care about the quotients. 102 goes into 138 one whole time, plus the remainder is 36. Since the remainder is not 0, we do the algorithm yet again. So we copy the equal sign, drop the previous number, we move 102 across the equal sign, and we reuse the remainder, which was 36. 36 goes into 102 2 whole times, plus 102 minus 36 times 2, we get the remainder of 30. Remainder is not 0, we have to do the algorithm again. So we have equal sign, move 36, copy the previous remainder, which was 30. 30 goes into 36 one whole time. 36 minus 30 times 1, remainder is 6. We apply the algorithm again. So we have equal sign, we move 30, reuse the remainder 6. 6 goes into 35 whole times, and the remainder is 0. Once you hit remainder of 0, previous remainder 6 is the answer. So greatest common divisor of 240 and 378 is 6. That's all.